All right, let's get started. To our Twitch viewers, thanks for hanging out with us tonight. We really appreciate it in this nice Wednesday evening. It's nice having you here. To our YouTube viewers, thanks for catching on another video and following along with this series. We really appreciate it. Definitely want to keep pushing for those likes and those subscriptions to our channel. No cost to you. Helps us out. And you know what? I want to be crazy and still push for 1 million subscribers by the end of this year. Hey, why not? You know, let's just be crazy and let's just see if it can be done. Probably not, but you know what? There's no reason not to see if we can push in that direction. Now to get back to where we left off in the last video, the last stream, we discovered that we had the problem using ADC Unit 2 while using other functions of the ESP32. And we had to perform some benchtop testing on a dev kit to test ADC Unit 1 with the LEDC driver, because that was causing a major issue where the ADC unit would not read. Found out that it works. So now we started incorporating the changes into the schematics, and we're going to push them forward to the PCB and make all the necessary routing changes as we have to. It should also push over any new test points if we've added any. But before we do, I want to get into the schematics and kind of run through each of the primary functional blocks and see if there's any other test points we want to add, because I want to wrap this up and get Rev 2, get the boards ordered and coming in, so we can build a Rev 2 version. Fortunately, we won't really need any parts. If I need to buy anything, it'll probably be the UART to USB bridge chips, for the changed part number. I still have a few, so I might be okay on that aspect, but I'll just double check my stock prior to that to see if we need to order anything. So through all our initial testing, we've validated we've got, the power supplies work. We've already made and pushed changes forward to account for some of the things. So let's go to the change log. Based on ECNs, add many new test points, move connectors outward, and extended the copper pores under the power supply ICs. We've already done that. Probably should do another ECN for switching the losing my train of thought here. The temp sense input from IO2 to IO32. That way it gets on ADC unit 1. And input 1 just generating GPIO input, so it doesn't really care. It's not using any timers. This is looking for a high or low value. So we probably should generate an ECN for this to do it the right way, because we want to keep going with doing things the right way. Folder, let's see here, project documents. So here we go. Let's see. All right, so there's that. And then we also need to go to let's see here, QMS. Logs. So we might as well just do it the right way. Let's not beat around the bush and do this the wrong way. So what we're going to do, we're going to do that, but we're going to rename it. it's going to be 2, 2, 25, 26, 01. So let's go ahead. Following all our numbers. To copy this value. Because we are basically approving it. And whoop. Brain's still on that. All right. So let's see here. Just let's make sure we know since which has issues with other functions, Wi-Fi, and also the LEDC system. Move, swap. Unit 1. There we go. Okay. Reason for change. ADC Unit 2 has issues with shared timers. It can be done necessary. Yeah, it's approved. So we have this. Let's go ahead and wrong thing. Let's come over here. ECR. That. Put it in the log. Over here. Home ECN. All right, so we have it logged properly. We've got a proper ECN, ECR ECN to follow it along, and that's fine. Now we need to go over here. Oh, I don't know why I closed that. I'm a goober sometimes. So that's it. So we'll go to KiCad over here. Let's go to the change log. Let's see here. That would be sheet 3. 3. Right, let's grab ECN. That should do it. Let's make sure it's all in here. Okay. Moved. Let's go back here real quick. IO2 to IO32. Let's see how this looks. It's moved. Two. Input 1 to IO2. Oh. All right, that's fine. That's enough of a descriptor. Oh, we got that changed. Okay, so let's go back to power supplies. Nothing there. USB 32. Okay, we have the new test points for RX and TX. I think they've already been pulled over to the PCB. Yeah, that's these guys right here. Ooh. 8 and 9. All right. So, all right. So that's that. RS45. We have test points already here over here. These are easy to grab onto a test point, if we need them. Limit switches. We've got test points already on these guys. Easy to check these because of the big terminal blocks. Same thing with the control inputs. USB UART. B bus and ground. We're watching. We can monitor. We can check that. RTS DTR. And we do have test points on the data, the USB data positive negative lines in case we want to look at that. And should be right here. So we've got those already incorporated. So yeah, that should be fine. I don't see anything else we can use test points on there. Driver. So we added a bunch of test points for monitoring the stepper chip, the 8825, and to check, to monitor the fan. We can clip onto an oscilloscope or meters or whatever we need to. So that should be okay. 5 volts and ground. Those are straight to the power supply, so shouldn't be a problem. Test point index. We have to go through and clean this up to match all of our test points because some of them got changed and moved around. So it's going to be a pain in the rear. Oh no, wait a minute. We may have already done that. Let's see here. 8 and 9. Let's make sure here. 8. Let's see. No, I think we already took care of it. 8 and 9. Yes, because we that's right. We created this test point index after we had made all these changes because this was a change that we added for revision 2. So that should be there because yeah, that should be in the change log. No, we didn't put that in here, but that's fine because it'd be in the ECNs. But I don't really see any more test points we absolutely need to add. We've really got a lot of the bases covered. Because like with stepper fault, we can pull that low to mimic, to lie to the microcontroller if we really wanted to. We could, get connected to any one of these test points then to see what's going on with what's trying to be told to the stepper driver. Sleep. I mean, should we pull that out? No, I'm not really going to worry about that. We're not even controlling it anyway. And as far as this design is concerned, we've got enable reset and all that. So having another pin to control or read doesn't really, control doesn't really make much of a difference. All right. So I think we're good with this guy. So what we want to do is next we're going to go over here, because now we get to have the fun of moving this capacitor and rerouting a couple of traces. So tools, update PCB from schematic, update, boom, close. So what we need to do, zones, vias, tracks and footprints. That don't go there anymore. Let's just get that cleaned up. Okay. So temp sense is now right here. There's room up here. Okay. Get rid of that via. All right, let's kind of clean that up a little bit. All right. Keep forgetting. So we can plug and chug this little guy like right here. Let's get him set. Okay. Make sure we got text. Got that. All right. So what we're gonna do then is we're gonna route. Drop a little via right there. All right. Got the ground line. We got that. Now we need temp sense. Where are we here? Don't need that guy. All right. Oh. We're going to have to rethink our strategy, it looks like. Let's get up to that guy. All right, so here's the temp sense line. Okay, well, here's where some of the problem. What do we have on the bottom? We'll have to see. We might have to kind of do some weird routing kung fu because now we need to go over to here. All right. Well, let's see what we can do. A little bit of track left behind. Let's see here. Let's get you. Let's get your via set up. All right. That's a plane. That's a layer. That's the green. Okay, or no, that's this guy. That layer. Let's not select footprints. So we can't really use that layer. But this signal layer. That's bottom. I'm able to use this signal layer. Yep, we can use a signal layer. Then the next thing we have to track is the input and figure out how to get it in there. Well, that looks like it's on the bottom. We might be able to clean that up. We'll figure that out here. But let's worry about the temp sense right now. Let's get that doing. Okay, so we're on the internal signal layer, temp sense. Grab this guy, and we're gonna just start routing you. All right, there we go. Got our teardrop, everything. All right. So we got the temp sense routed. Tracks and vias, that's fine. So let's see. I think that's on the bottom. Yes, sir. No, that's going to be a problem. That's input 1. Which is right. Oh, actually, we want be able to. Okay, it goes right here. We might be able to top layer that. So let's get rid of these traces here. All right. Okay, let's see. We top layer that. Oh, you kind of come around. Come around, up and down. We can't. Why make it more complicated on ourselves if we don't have to? All right. Tools. I know there's a fill all zones. Went through basically fill all the polygon pores, all the copper pores. Okay, that looks beautiful. So solve that. There's no stray parts sitting around out here, so we got all that plugged and jugged. Looks happy and fine to me. The copper pore with the extraordinary amount of vias tying the ground layers and to the bottom copper region too to help dissipate heat from the power supply chips. Even though they don't generate a ton of heat, they still just generate enough on their own, especially when they're fully loaded. We want to do everything we can to possibly sink that heat out. So that's why we did this. Because with our deep testing that we were doing with the resistor load box, I'm not 100% sure if it was just overcurrent or just because it was heating up, but using the infrared thermometer, we could definitely tell the board was warming up. So let's see here. Let's grab some text. Let's make sure that 02, yeah, revision 2. Unfortunately, we'll have to not only order PCBs, but we'll have to get new stencils as well. I was trying to avoid that, but hey, them's the breaks. That's fine by me. Get new stencils in. Won't need to really, like I said, order too many parts, with maybe the exception of this UART bridge, but I'm fine with that. We can make it work. Test points. They don't look half bad at all. So I'd say we're good to go there. They're as logically blocked as we can place them for the functions that they're measured. Oh, yeah. Whew. Pardon me. For what they're there to test. All right. So I guess we start over with we get back into the typical routine of, one thing we'll have to get the bill of materials updated because we're adding all these additional test points, which would be a little bit, it shouldn't be too difficult. For one thing, we just really added a capacitor. Right. Let's see here. Project documents, hardware here. So we're in version 2. So we have the bill of material. I can close that. And didn't want to open it in Excel. I wanted to open it in LibreOffice. Not like it really matters because it's an Excel file, but file, version 2. All right, so what we're going to do is go to the schematic. The capacitor we added is C30 and it's a 104. So what we're going to do is find the 104 caps, which are right here. So we're just going to manually update. All right. So we have 12, and I said, what, C30, short-term memory is just, yes, sir, C30. Let's come up here, dash C30. That way now it gets accounted for. Holy crap. All right. Yeah. Okay, so we have that. And test point index. We have 36 test points. So we can go back to here. That's what these guys are. So we have oh my gosh. Yeah. 36. And there we go. A little bit easier than just trying to export it and get everything brought back in here. PCB version 2. All right, so tape for heat sink. None of this has changed. That's the only additions were the new capacitor and the extra test points. So okay. So that should take care of all that. PCB 02. All right, so that's that. We have that. The bomb version. This is all okay. It's beautiful. Oh, I thought I saved it. Oh well. So again, this is looking good. This guy's looking good. So what we need to do then is start our basic review process. Excuse me. Saved. Okay. So what we need to do is kick out the manufacturing files. File. Application outputs. We have the Gerbers. Oh, okay. Here's where I select the directory. So we'll use that. Nothing else should have changed since the last time we did it. All right. No, won't need that. I think it'd get plot. And looks like we can go in and generate the draw file. Excellent. Yep. Whoop. Close. Come here. 02. All right. So now we have the Gerbers, and I think we've got the drill files in here too. Yep, there's the drill file. Non-plated through hole and plated through hole. All right. So we have this. So what we need to do is minimize that. All right. Well, I think it's view. That's right. All right. So we're going to grab all this stuff here and drop it here. All right. So let's go ahead and start getting rid of stuff that we don't need for this and start, again, organizing this so that it's easier for us to read, easier for us to figure out what's going on. All right, so I think this is the dimensions. That can go away. We don't need that as part of the file. So let's go ahead and save project. Grab that. No. Personal. Hardware. Yeah, that's what I want. And put 2-02 for version 2, Gerber review. That way it's saved, and then we could go through and make all the required changes to it. All right, so let's go ahead and there we go. That is the top layer, or the top silk screen. Going to, again, kind of wish there was like a script we could run. All right, it's top copper. So if we're going to kind of go by the colors, that's red and then blue. Yeah, change that to red. Okay. Okay, mask gets put on top of the copper. We're going to just do green. Because remember, those are where it's actually open. So it's kind of like a negative view. Paste, same thing with the paste. It's a negative view. So just to keep that in mind. So that will be there, and we're gonna make that gray, close to silver as we can. Save it. All right. So internal layer 1, 2, 3, and 4. That's fine. These are drills. Don't really need them, but you know, at the top. Edge cuts. That is basically the outline of the board. Put that all the way at the very top. And let's give that a nice bright color. Brilliant red as well. Just so it's more visible. Okay. Bottom copper. We're going to kind of place on the bottom because of the way it stacks. We're going to kind of try to copper. We're going to make that blue. And then, let's see, copper and the paste. Oh. And the mask. Yeah, like I said, it'd be nice if there was a script for this. Green. Because again, the silk screen, that is the overlay. And that's going to be white. Oop. Okay. All right. So let's start working around the top of the board. Let's hide everything. All the layers. All right. So edge cuts. That's the board perimeter. The silk screen. Obviously, they're overhanging, but that's fine. That happens. Manufacturer might come back and say, "Hey, what in the world's going on here?" But no, that's perfectly normal of a thing to do in these type of things. So right now we're just kind of like, okay, so these are the drills. It's kind of getting them like a kind of colors a little bit out there. So one's plated through hole and the other is non-plated, but it's fine. Let's just make them look the same. So those are just the holes, just the drill holes, and that's fine. So basically vias, through holes, things like that. That's what those are. Test points are through holes. You know what? Let's give the non-plated a different color. You know, let's make it pretty yellow. Okay. So basically, those would be those two indexing pins on the USB-C connector. The two holes are not plated. They're just holes drilled in the board. All these purple ones are plated through holes. But like I said, vias and test points and all that. So that's what that is. That looks okay because they look like they're on the right spots. These are the staking holes, if I'm not mistaken. Indexing and staking holes over here. Some vias. All right. So that looks good. We will hide those. Don't really need those. So the big thing we want to look at is, okay, just kind of like look at the silk screen. Just kind of, does it look horrible? Does anything look like it's overlapping too much? Nothing should have changed too much. We did kind of have to offset these guys because we moved the connectors, obviously. But nothing looks like it's out of place. Nothing looks wrong with the top silk screen. We're going to go and bring up the mask. So these are, so it's easier if we bring up those with the copper. So these are openings in the solder mask layer. I don't know why they're not open on these guys, whereas they should be. The manufacturer didn't complain about them last time. I think they assumed that they were open because they were plated through holes. So I don't remember getting an email about that. So I'm not going to terribly worry about that. So one of the reasons I want to bring up the copper layers is see where and leave the overlay so we can see where the parts are, and kind of make sure that the green is actually in fact on top of pads. So again, it's a negative. So all the void space in here that's not green would be green. And then the green spots on here would be bare copper, basically. So that's the way you got to like look at this. So those are openings in the solder mask. So it's a reverse. It's kind of like a negative image. Mainly you wanted to check your SMT pads and stuff for everything. Make sure you don't have any pads for SMT components that are covered. So that looks good there. We're going to do the same thing with paste mask. This is for the stencil. So we want to make sure that anywhere that you're going to be placing an SMT component that gets solder paste is going to be pasted on the board. The opening is there. So just now notice there's no solder mask opening. I mean, there's no opening here because there's obviously no solder paste. Got the paste openings. There typically aren't going to be paste openings for through-hole parts. Well, technically we could, have it put solder paste down here where the staking pins are going to be and try to reflow them into the board, but we'd still have to touch them up with a hand iron, so it's not really that big of much of a change. So I think this looks good. This part looks fine by me. We're gonna and then inner layer 1, which is a power plane. So this would be the ground plane. Yeah. Let's double check. Plane 1. Yeah. Yeah, which is the ground plane. Okay. So if we go here, all the drills. Let me make sure this is actually the ground plane. So in that run of, let's try to orient that. 2, 3. Okay, no, that's actually the power plane because this would be the 3v3 plane. Okay. Yep, so that's 3v3. Okay, I have it backwards. So that is the 3v3 plane. So okay. So all these plated through holes that have the big gap around them, those are basically obviously not connected to the plane. But all the drills that have like this, the thermal relief, or just directly tied, they actually do tie into 3.3. We're just kind of making sure that there's no weird anomalies here in the Gerber files for where there's not supposed to be any connection. That's really all we're doing, all we can do. Oh yeah, so that's because there's a hole there. Non-plated through hole, that's right. So if we highlighted that again, it would show these guys. So yeah, that's why you're not connected. Not like it needs any clearance, but you get automatic clearance from that. Okay, that looks fine. So then this would obviously be a signal layer. We're just checking to make sure no weird anomalies happen to where the signal is somehow getting crossed into like a polygon or a through-hole part inadvertently through the translation of actually converting it over to the Gerber files. That's all we're just looking for. We're not looking for anything groundbreaking or earth-shattering. We just want to make sure nothing's accidentally shorted out, like the Gerber interpretation didn't get messed up. Excuse me. And there'll be a little bit better resolution anyway when they go to actually image and generate the PCB itself. The state of their equipment they have. So then this is the ground plane. Now, obviously, I should have picked up on that with this little cluster of plated through holes, all those vias, the ground vias, for the polygon pores underneath the power supply chips. Again, just kind of making sure that nothing's weird with these openings. We don't see anything just kind of like anomalous. And everything looks fine there. No weird anomalies. So now we're going to go to the bottom copper. I remember, so this is viewed from the top of the board. We're not flipped over. So we're going to get the bottom silk screen. Now, idealistically, what I should do is try to flip everything, but sometimes doing that in this software just kind of messes with everything. You just kind of got to remember it's flipped, it's mirrored, because you're looking at it from the top instead of flipping the board over. But it's going to be the same thing here. So we're looking at the silk screen. Nothing's like crazy. Nothing looks out of place. Don't have any major overlap with any of the outlines. Blah, blah, blah. We're looking okay there. We're looking beautiful there. Beautiful, beautiful. So we have that. Now we have the mask. Again, same thing. It's an opening in the solder mask. Okay. Mainly for the SMT parts. Nothing anomalous, nothing broken. Now we're going to go to the paste. Again, nothing anomalous. I know we did this on the first revision for those who have been following the series thus far, but these are processes you should always follow every time. You don't want to skip leg day, basically. To put it in other terms, you don't want to keep skipping things, because that's when things come back to bite you. You may have verified once, but that doesn't mean that the next time you spit this data out, it's going to be correct. You always check. Always double check your work. And again, said it before, if you can have somebody else double check your work for you, and make sure that you're not missing something, a second set of eyes or even a third set of eyes, there's nothing ever wrong with that. So if you have somebody like a part of a team, a friend, somebody who does this stuff as well, and you want them to look over your work, definitely have them. Sometimes them not being a part of the project helps, because they can catch stuff that you miss. And always be humble when somebody does catch something, because it's a great learning opportunity, and it's a great opportunity for the project. So always be happy when somebody finds something that you missed. So everything looks good. Our text is fine here. Again, we should be having like a checklist for this, and I do admit that it's like a fault of mine. Again, documentation is something that's a must, but it's also something I'm really poor at, and I'm working on trying to improve it. And that's what I want to do with this series. That's what I was hoping to do with the series. So again, we're going to be getting this board sent out, getting the ordering PCBs and stencils, and then have to wait for them to come back. And that'll give us at least a week before they show up, before we can build any more boards. So we'll have some time to catch up on some more documentation, maybe start formalizing some of this stuff, more of this stuff. But right now, this looks good. This looks really good. I may have to order more test points. We may run out of those, so I may have to pick up more of those, and I might just go and order some of those and some of the other stuff. But what we need to do is, I'd say we're good. We're just going to turn all this back on for now. That way it's out of the way. Save it. So that's the Gerber review. This is good. So that's good. Let me get over here. Get over here. All right, so we get to do some more fun stuff. Back to our favorite ERP, MRP system, Odo. Because again, we're still make sure nothing's left here. So we got to go to inventory. Products. Okay, bare PCBs. So what we can do then is we can duplicate this. All right. Let's go and rename it for version 2. Oh, I hate you that you did this. Don't do this to me. Bare PCBs. Gotta get this. Because remember, it uses, Odo likes to use the reference. So if you have references that are duplicated, it will get mad at you regardless of what your product is. I wish we could do it the other way around, but Odo does not do it. So we want it, that's why we put Rev 2 in here. So Rev 2 board, everything's still the same. Did I put a vendor in here? Yeah, JLC PCB. I don't know why. It doesn't duplicate that, but that's fine. Again, I'm going to save. I'm going to switch the order of these because I like to have my reference here. Okay, so we have that guy there. Rev 2, there's 0 on hand. That's fine. Now we need to go to SMT level assembly. Oh, we already kind of did it. Rev 2. Okay, so Rev 2. Now let's go to the bill of materials, because we do need to fix this. Rev 2. Okay. All right. So this says we need 11 of the 0.1 UF capacitors. I don't know why I leave the bomb open. Probably because I didn't think we'd have time to kind of start going over some of this stuff. Just worked for me. Okay. Okay, we need 12. Okay, so 6 of 3, so need 12. And then test point. That's actually through the assembly work. So that is taken care of. All we had to do was just add 1 capacitor to this. Products. And then, let's make sure it's got the, I know. All right. We might as well just do it down here. 02. I think, yeah. All right. So, yep, we need to make sure it's Rev 2. Okay. Good. Okay, so that's for that. We need the assembly level. All right. Here's where we, here's where we need to grab this. All right. To duplicate. And then we're going to go here. Assembly. We're going to go here. PCB 02. And we're going to go here. Oh. 2. And again, we might throw in a final assembly when we're all done through our initial testing. There probably will be a final assembly, which will include the plastic pieces and all the other hardware to put it together in the case. But for now, okay, so I think no. I think okay. I was able to duplicate. All materials. Okay. Can I rename it? And there was a way I was able to do this. It's fine. I've got it. Wait a minute. There was a way we were able to do this. Oh. Import records? No. Create new. I was able to do it once. I'm trying to remember how we did it. All right. Oh, actions. No, I was able to somehow tie it. Materials. Hmm. Wait a minute. Bill of materials. No, how do I do it? Oh, where did I do it? Oh, I was able to do it before. Oh, it's driving me nuts. Okay, so I know I was able to do it in the SMT version. Bill of materials. No, I don't need to import. Oh, wait a minute. Operations. Overview. Okay, that just completely broke. That completely broke what I was trying to do. What in the world? How they... Oh, that's right. I was able to... That's right. Assembly level 2. Okay, that's it. Okay, my bad. So that attaches that bomb to that version. So we don't need a PCB1. We need a SMT. So we need an O2 PCB assembly. And then how many? 36. Okay. Nothing. No. I'm so used to hitting Control S to save stuff as I work. All right. Nothing else should have changed because that's the fan assembly. Okay, nothing else should have changed other than Rev 2, and then this is Rev 2. So let's save it to products. Let's make sure. Assembly level goods, PCB assembly, bill of materials. All right. Okay. All right, so we've got that. All right, let's duplicate this. 0, 2. Bottom. And again. That's the bottom. Probably deletes it so that top. Yep, so when it duplicates it, it doesn't have a problem. It doesn't have that issue. 2. All right, so which is good. We didn't have to add any more components to our library. So we just had to update some bill of materials and get things kind of cleaned up there and basically add our new things. So let's go to manufacturing. Do 1. All right, so let's kind of go. Let's give us. Whoa, that's freaky. Back-to-back months with Friday the 13th in them. Okay, that is really freaky. I didn't realize that till now. Huh. So March. Thankfully, April breaks it. That would be even weirder. Okay, yeah, that just kind of threw me for a loop. So go to March 20th. We're going to go and confirm this. So we're going to also do assembly level 1. We're going to do Same due date, that's fine. We're going to confirm. Now, it's going to complain about the fan. We do have one additional fan, so, you know, let's go ahead and... okay, let's do the fan assembly. Let's set it for the 20th as well. Apply. We're going to confirm it. That way, it's going to get generated. And we have that. We have it. I was going to assemble it anyway. We might as well just go ahead. That way we have it. And then there's some tricks we'll have to do with Odo with inventory to basically undo some of this stuff. And lie to Odo about some of the stuff, you know, materials that we don't have. So SMT, what we need PCBs. Okay, so it's saying we don't have the UART bridge chips, and I believe it. I mean, I know we have a couple. Don't want to rob Peter to pay Paul. Probably not. I'll probably just order a small handful of them. Get these ordered, and then assembly level. So we need that. We need that. So it says we have enough of these guys. All right. And all right. So let's go to inventory. I should just. That's why I like using tabs for all this stuff. Let's go to. I called them connectors. TP. Oh, okay. So it says we have 77 on hand. Okay. So in order to build more boards than this, we'd probably be able to build 2 more boards with what we have on hand. But, you know, that's fine. Right now, we're just going to be making sure we have enough parts to just build 1 additional board. So I'll work on getting those things coming in. And we will go from there. Probably the next video will be just a quick status update on parts coming in, and then we'll start updating and catching up with some of the QMS related documents. Get some more of the kind of take the test process, rewrite it, clean it up, add the new test points to it, and things like that. I've got some new ideas on how I want to do this, clean it up a little bit, like I was saying. I started off using the Markdown language. It's nice, but you can't do some really nice formatting with it. And again, LibreOffice is free, and we could just use it. And that's what we'll do. Just kind of rewrite everything and kind of make it nicer to look at, easier to read, much easier to edit. Sometimes reading the Markdown language gets to be a headache, and I admit we could do better, and we will. So that's probably what we'll start focusing on the next few videos while we wait on boards and stuff to come in. So until then, until our next video, I thank you for hanging out with me this evening, and catch you later, and have a good rest of your night.